Hi friends, good morning to everyone. We have discussed the fundamentals and functions in C++. The last class we have seen the scope and storage class, local variables, global variables, static local variables. Now we are going to discuss right in this session how to return variable using the reference concept. Normally a function can return only one value to the calling place. In case if we use the structure, using structure we can return multiple values to the calling place. That means a structure can return the entire value, the entire members to the calling place. Normally a function returns only one value to the calling place. In some situations a function can return the reference to a global variable to the calling place. Right, this is strange, but this concept is right applicable in function overloading a concept. And now see this example, right, so that you can understand how a function can return a global variable as a reference right to the calling place. So see this code while returning returning a reference from a function. Define the header file hash include iostream.h. Then define one local variable, say int x. Int x, right? This is not a local variable, right? A global variable. What is a global variable? What is a global variable? Anyone? What is a global variable? Ganga, Harini,
It can be used in any function, sir.
it can be used in the a variable, right, that should be made so that its visibility, right, should be available in any function. That stage we need to declare a variable as a global one that can be defined right before the main function section. Now defining one main function into main, let us define one variable int x, right, that has already been defined. Now define one function, say int assign x. Let us have a reference to this function int ampersand assign x. Let the function return a value x, return x. X is the reference, right? A global variable. That reference is right returned from the function definition. So define the function prototype int ampersand, or we can define like this int ampersand assign x function prototype. The main function. Normally, how will we call a function? How can we call a function?
By function name, sir.
Function name along with the parameter list, right? Different. Very good. Now, right, to call a function here, right, we need to use the function call here in the left hand side. That's what I said, right? It seems strange to us. Assign x function call, this is equal to say 100. Then we do want to print the value of x. See out x is equal to x. Have a look into this example. X is a global variable. The function rate returns a reference to a global variable. To where means right to the main function, right, it returns the reference to a global variable, because the global variable can be accessible anywhere within the function. In that case, right, we need to define the reference like this int ampersand, right, function name return x. X is a global variable, so that here when you return a value x, what happens, the reference to, right, the global variable or the function simply returns a reference to the global variable x. So simply here assign of x, what is actually received in the left hand side. In the left hand side, it seems that the reference, right, to a global variable, that is x is received. So it seems that the value of x will be set to 100. Then C out x, right, we can see, right, the value of x is 100. Let us save the file, save cxx22. The program has been compiled successfully. Then running the program, control F9, it seems the value of x is 100. The thing is, here the reference concept, right, should be introduced. We can define the reference like this: int ampersand space assign x or whatever is, right, int only assign s is missing here, ASSIGNX F9, or as we defined here, control F9, have the result x is 100. So define, right, like this: int ampersand assign x, right, as a function reference. Int ampersand, this indicates that the function is returning one integer reference. That integer reference, it should be a global reference. That means the variable, right, should be a global variable int x. Only in that case, the global variable's reference, simply here the value x is set as 100. In other cases, right, for example, if you want to return a value some constant, right, so I am trying to return, right, in the another example, right, I make it cexx23, returning a reference from a function, right, what is actually not allowed, right, we cannot return, we can't return a reference as a constant. That means constant references are not allowed. For example, in this example, we are modifying return, suppose 10. Now what happens? 10 is the integer value. We are trying to return this integer reference, right, as the value 10. In this case, compiler reports the error message, right? The error message is reference initialized with int needs L value of type int in function assign. L value means, right, there should be the left hand side variable, right? In that case, right, L value error message will occur. So you cannot return a constant reference to this kind of a calling this. This is not allowed, right? This results in error. Second thing, we cannot return a local variable as a reference. can't return a reference to a local variable. In case, right, if we define one local variable here, int x is equal to 25, return x. In this case, the error message is attempting to return a reference to a local variable x in function assign x. Because assign x data, this returns a global reference only, but we are trying to return the local variables reference. So in this case, what happens? It returns the compile time error. So these things are not allowed, right? When a function returns a reference value. Reference value means, right, it returns only a global reference variable. Local reference variable are symbolic constants, right, are simple constants, right, will not be returned as a reference to a calling place. This kind of, right, returning references, right, will be useful in overloading concepts, right. Later, right, when we explore overloading, right, you will understand in detail, right, regarding these function returning references. Do you have any queries? Having any queries?
No, sir.
One more topic, right? Another one is, right, type costing. Type costing. Type costing, right? This means, right, converting the expression value, right, into the required type, right? In some situations, right, we have introduced, right. In this example, see, right, how type costing is applied in C++. Hash include IO stream dot h into name. Suppose int x is equal to 10. We can write a float a is equal to, or float a is equal to, if we write 10 by 3, try to print the value of a is equal to a. What is the value of a in this case? What is the value of a? Expected value of a. 10 division 3. 10 is the integer quantity, 3 is integer quantity, integer by integer. The result is evaluated in the integer mode. So it seems a fractional point, right? This will be lost. Only the integer value 3 is assigned to the left hand side, right? So you can see the result, right? A as 3. A is equal to a, float a, 10 by 3, right? This results in a 3. In case, right, if you want to have the exact result, float b is equal to, we can perform the typecasting. For example, float of numerator 10, division 3, cout less than b is equal to less than b. The value, right, 10, 10 is typecasted to, right, the are converted to the floating point type. In this case, right, the numerator 10 is, right, made as 10.0 as a floating point quantity. When numerator is converted into a floating point type, division denominator is an integer one, right, floating point by integer. What happens? Float by integer, the result is converted to a floating point type. So we can expect the result, right, a 3.333 something as a floating point quantity. So here this is one way of performing, right, typecasting, right, in C++ language, a float of 10. Float means right data type. Specify right this syntax. Data type. In which type right the expression needs to be right converted. The data type expression. Or if try to write this type float b is equal to float of 10 division 3. Numerator is right a type of floating point type. Only the parenthesis right have a significant one. Parenthesis right can be right put to the data type right like this. Or this can be right put to the specific expression. So data type expression otherwise based on the expression we can write data type then hash equal data type the expression can be right parenthesized. This is to be the type casting, right? Converting right the lower type into the higher type, right? For the required type, right? We can perform this kind of a type casting. Even right, if there is a fractional point, right? Fractional point, right? It can be right truncated using the integer conversion, right? If you write int of 10.0 by 3 point, right? 0 fractional value 3.333 right then that is truncated to the integer one because of integer type casting. The same right type casting is supported in right the C language using this general form or you can apply this general form. The next one is the const keyword. Const keyword or you can say const as a qualifier, right? The purpose of const keyword is to define a symbolic constant. How will you define a symbolic constant in C language? How will you define a symbolic constant in C language? Anyone? Symbolic constant, how will you define? Suppose const int, okay, take it to float, right? Const float pi is equal to 3.14159. See out pi is less than pi. How will you define a symbolic constant in C language? Once we define a constant, right, the constant should not be updated, right? It should not be changed. So to make it as a symbolic constant, what is the syntax to be used? Anyone?
So hash type defined, sir.
Hash, hash define, okay, hash define. For example, you can write like this, hash define print 43. You can print, right, the value of string. How to print, for example, see out strength. Now a strength is defined as a symbolic constant, right? So this means that you cannot change the value of a symbolic constant. So once it is defined, that's all. You cannot change the value. CVXX. 24 3xx 25. Okay. Once you define a symbolic constant, you cannot change its value. In this, right, the value of a pi is treated, right, using C++ type. Const float pi is equal to 3.14159. So once the floating point quantity pi is defined, hereafter, right, the final value of pi is the same. You cannot change. Like in C language, has defined strength 43. Strength is, right, a variable, right? So wherever you want, you can use it. The value 43 is replaced here, right? Like a macro. Here in C++, right, float pi, const float pi is introduced. So subsequently, right, if you introduce pi plus plus, this results in the compile time error. What is error message? Error cannot modify a const object in function main, because, right, a PI is defined as the const object or a const qualifier, right? This results in error. Likewise, you cannot modify, right, strength plus plus. This results in the error message, right? L value required in function main, or writing strength is equal to 100. L value required in function main, because strength is a predefined constant one. Its value rate cannot be changed during the execution of the program. We can also define the const references, right? See the next example. Like, see, like alias, we can also create the constant reference alias. Alias for const references. Hash include iostream.h int main and define const int x is equal to 10, int ampersand y is equal to x. What is x? X is the integer variable that is defined as a constant one, and the value of x, y is equal to y less than dn dn. Now int ampersand y is equal to x means, right, y is an alias. So in this case, both x and y are pointing to the same value. Control F9. X is 10 and y is 10. Since x is the constant integer variable, right, this indicates that x cannot be incremented. Suppose x is equal to 12. What happens? This results in the error message, because as usual, this is the constant object, right? Constant object cannot be modified. This results in the error message. So int x is equal to 10. The final value of x is 10. X is equal to 12. This results in error message. But what is y, right? Thinking y. Can you say, right, what is y in this example? What is y in this example? Yes, make it fast. int ampersand y is equal to x. What is the name given to the variable y? Anyone?
Alias.
Alias. Okay, alias, right? That means the it will not create the different memory location. Same memory location of right x is introduced, right? Used here. So x is 10, y is also finding the same memory location of x. So y is also updated to 10. Since x is the constant object, right, it cannot be modified. But what about y, right? Y is not a constant object. So we are trying to write update a value of y is 25, and try to print the value of x, right? What will happen? This is perfectly valid because even though right x and y are pointing the same memory location, the speciality or restriction of x is a constant one. The name given to x is a constant one. So that the value of x, right, using x, right, you cannot change the value. That means x is equal to 12 or even x is equal to 10 again, x is equal to 0. Here, this results in error. But what is y, right? Y is an alias, right? Simply, y can access the value of x. Y, right, itself can modify the value of right y. That is possible. So y is equal to 25, but then subsequently printing the value of x, right? What happens? Y is equal to 25, right? Then printing the value of x, right? The value of x is printed as 10, but try to print the value of y. See out less than y. F9. File has been saved. Control F9. Y is 25 because we are updating rate y, but in the same memory location we are updating the value right in terms of a variable y. So y is updated to 25, but printing the value of x, right, x remains right 10 because x is right the constant object. You cannot modify the value of the constant object. In the same way, right, using function call, you can pass some parameter and you can define right the local parameters, the const int type or const type, so that when the local parameter, right, formal parameter receives the const type, then further right changes right will not be allowed right inside the function definition. So simply saying right const objects right cannot be right modified. Similar to right hash define right a symbolic constant in a C language. Once right we fix a value, that's all. We cannot change the value of the variable. Similar to right hash define a preprocessor directive right in the C language. The same can also be right done in Java language. There right you will know right in your next semester using final keyword, right? The equivalent implementation of const int x is equal to 10 in Java is using this final int x is equal to 10 semicolon. Once a variable is declared as right a final one, that's all final. You cannot change the value of the variable. That way, right, we can define a symbolic constant in the Java language. Have any queries? Having any queries? Next, we are right moving on to right this topic, objects and classes. We are moving on to right the core concept, right, objects and classes. So in this session, right, we focus on how right a C++ implements right the concept of objects and a classes. How C++ defines the concept right encapsulation. How to define right the encapsulation. How a class encapsulates both the data and the functions into a single unit. What are the accessing rules of right classes and objects in a C++? How C++ objects right can be made as right similar to right a physical objects, right? How the link between made right the physical objects and the C++ objects, and what are C++ objects actually, right? What kind of data types are right, supported for C++ objects. Then we need to focus on right constructors and destructors and how a function can pass the object as a parameter and how a function can return the entire object as the return value. So this is the focusing. So entering into the right core concept objects and classes. In a C, A++, right, we have a keyword called class. Class is a keyword. So using the keyword class, right, we can define the class name. For example, have a look into right this open book. 1 minute. In C++, we need to use the keyword called class to define the encapsulation that that right combines right both data and functions into a single unit. So using the keyword class, the user defined class is defined right in the syntax class name. Following that, we need to define the members of the classes. To define the members of the classes, we need to use the access specifiers in the C++ language. There are some access specifiers in C++. They are private, public, and protected. Specify right the region of the class right into these things: a private, a public, and protected. Then we can define the corresponding members in it, right? So members can be of any type, and we can define the corresponding variables or functions collectively, right? They are termed as members. So general form of a class declaration in C++ is this way: class. Following this, we need to define the name of the class. Class name is the user defined type. Then within the opening and closing curly brace, we need to define the members of a class. So the class members right fall into right three different regions. They are private, this is a keyword. Another one is public, this is a keyword. And protected, protected is the keyword. These are said to be access specifiers. Access specifiers. Access specifiers define right the access specification rules how a member is going to be accessible. Protected right will have a significant only with respect to inheritance. So as of now, right, just ignore the access specifier protected. More about the protected, right? We will explore when we discuss the inheritance concept. So as of now, right, consider only right the two access specifiers, private and public. After right private and public access specifiers, right, the colon should be introduced. Private colon, public colon. By default, the access scope in C++ is a private access scope. Where in Java, right, by default, the access scope is a public one. That means here in C++, right, if you miss right private colon, by default the members means right in C++ the term members that means data member or a function member or say member function. Data member right this means right the data right are simply right the variables that are declared inside are part of the class. These are variables. Member function, right? This is nothing but simply the functions similar to, right, as C functions. Collectively, the variables and the functions are said to be the members of the class. So by default, right, if you miss the private colon, missing, right, the private colon, in this case, the default access group, private, is considered. The corresponding variables and functions will come under a private access group. Otherwise, we need to explicitly specify the public access group using the keyword, right, public, then a colon. So inside, right, the class private colon or public colon, what we can specify further, we can define, right, the variables. So how to define the variables? We can define the variables, right, using the normal format, right? So in the normal format, how to define? We need to define using the data type, then function data type. After that, specify the variable name. 1 minute. Class, class name, then within the opening and the closing curly braces, followed by semicolon, because class is the user defined type, ADT, abstract data type. Class name, right? This is the user defined name. Class declaration ends with a semicolon. Then within this opening and closing curly braces, we can define the private as well as public sections. For example, explicitly, right, we define private colon. Here explicitly defining public colon. Inside this private and public, we need to declare the variables and the functions. Here, variable declaration, then function declaration. Likewise, in the public area, we can define the variables, variable declaration, and functions can also be declared and are defined, right? We see how a function can be defined or declared, right, inside the scope of the class and outside the scope of the class. So simply, right, if you consider the class, for example, a student class, class student, within the opening and closing curly braces followed by semicolon, we can define the region private colon, say into roll number. We can define the functions, right, if you want. Then define the public section. Public section, for example, I write int or another type, right, float average. Then function declaration. Function declaration, for example, void get input semicolon, void display semicolon. Assuming that the class consists of the two sections. One is the private section, which consists of an integer variable roll number. Then in the public section, one variable average is there, and two functions are, right, declared. Right, one is get input function, and another one is display function. Following that, right, assume a closing curly brace, right, followed by semicolon is there. So what is a class? Simply, class is a container for both data and functions. Both data and functions are combined into a single unit called class. Inside the class, right, we have two sections, right? As of now, one is private and another one is public. By default, the class members are coming under a private school. Then inside the class, right, in private and public, we can have, right, this kind of declaration, variable declaration and the function declaration. We can also define a function, right, within the scope of the class, right? When the function definition is very small, we can define the function definition within the scope of the class, right? As usual, return type, function name, parameter list, right? This way, return type, function name, parameter list, then function definition within the opening and closing curly braces. Like a C language, right, function. Here the function can be defined right within the scope of the class declaration. Then coming to the accessing rule, the data right that is defined inside the private part is hidden. Private section, right, this will not be accessible, right, from the outside entry. Only the public section variables, right, can access the corresponding private entry. Private section right can have multiple functions. The functions can access the private data or the functions can call the corresponding private data. But logically, public section can access the corresponding private section. Public section right can be accessible by outside functions, say main function. Outside function can enter into only the public area where outside function cannot enter into the private area because whatever we want to have right as a secret, right, that should be hidden from some other right functions. Then here we can achieve the data hiding property, that is security property. Data hiding, to achieve the data hiding, put the relevant data, required data and functions, right, within the private section, right? Even you can place the functions inside the private section, but data hiding, right, hiding the data from right some other functions. So better to put right some variable declarations are private data only in the private section, because public functions of the same class right can have the rights to access the private data, but there is no direct entry allowed to access the private data. This is not possible because data hiding is supported here. So once you declare a class like this, class name, right, and defining the variables and the functions, then the next step is right creating an object, right? So to create an object, you need to use this general form, because objects are right simply instances. Objects are nothing but instances of the class. Objects are also said to be instance variables. As we discussed the earlier, right, in the fundamental concept of object-oriented programming, when we create the object, the corresponding memory is allocated by the system. Suppose the class name is like sample, class sample. Then to create an object, right, you need to use this form, class name, then followed by object list. For example, we can write S1, S2, S3 semicolon. This is nothing but the class name. So the syntax to create an object is class name, then object list. Object list is a set of variables that are separated by the comma operator. So once you create the object list, right, then you can access the corresponding public members of the class. Public variables are public member functions using the dot operator. This is it to be the class member access operator. or class member access operator. How the dot operator is employed means, right, we need to use the object name dot class member. This is valid only when the class member is available in the public section of the class. Whatever is the class member. Class member may be a data, right? That means a variable, or it may be the corresponding member function. So to access the member function, right, or to simply to access the class members, we need to use the dot operator. These are the basics in objects and classes. Now let us verify, right, this structure with one example. Class and object in C++. First include the header file hash include iostream.h. Since the C++ is said to be a bottom-up programming approach, in the style, right, first header files are included, similar to, right, the C language. Necessarily, right, include, right, the header files at the beginning of the program, right, based on your application. Then you need to define the class function, right, or class declaration. Class, for example, student. Then within this opening and closing curly brace followed by semicolon, we can define the private section as well as public section. Private colon, then public colon. Inside the private colon, right, we can define the variables, for example, int roll number. Then public section, we are defining one variable, for example, float average or float CGPA. Then declaring, right, some functions are defining some functions, right? Here let us define the functions. Void get input. In this opening and closing curly brace, we can write the statement cout enter roll number and average. We need to get input through the cin statement, cin roll number greater than average. So one function get input is defined. Let us define another function void say display. Here let us print the values of roll number and average. Cout less than roll number is less than roll number less than slash t average is equal to average is less than average endl. So the two functions are, right, defined inside the scope of the class declaration. Our class is, say, student class that consists of, right, some a private as well as, right, a public member or functions variables. In the private, right, one roll number is one integer number is defined, and in the public section, right, one variable abg and two functions are defined. Then we are going to define the main function section into main. Have a look into the statement. Return 0 inside the main, right? If you want, we can start one message cout main starts, because program execution begins at the main method, main function. We need to create an object of, right, this student class, say student s1 comma s2 we do like to call the function s1 dot get input, then s2 dot get input, then printing the results s1 dot display, then s2 dot display. Let us save the file. EAX27. Have a look into write this compilation. There are no compile time errors available. So in our case, right, a class, right, a simple class student is defined. Have a look into right how to define a user defined class in C++. Class, then class name. Within the opening and closing curly brace followed by semicolon, right? Inside that, you need to specify the data members are simply the members of the class. Members of the class are simply nothing but the variable declarations as well as function declarations or definitions, right? Whichever is. In our case, right, one private variable is declared, right, in the private section, and in the public section, right, avg is declared. Then the functions, right, get input and display are defined inside the scope of the class, because the function definition get input takes just 2 lines and display, right, takes just 1 line. So minimal number of executable statements. So these are defined, right, like inline functions or automatic inlining. This is nothing but automatic inline concept, right? Because the function definition is included inside the function inside the class declaration itself. Then to access the functions, right, we need to create an object. Object, right, to create an object, we need to use the class name. Class name space object list or the object list, right, should be separated by the comma operator s1, s2, s3, etc. Then to invoke the functions, objects are responsible to send and receive messages. As we discussed earlier in the fundamental concepts in object input, right? First, the object input, right? First, the object s1 is created, then input value is initialized, then s2's input is initialized here. The contents of object s1 and s2 are created. So, soft now, right? Have a look into, right, this outcome. Main starts because program execution, right, begins at the main method. Now for the first student, right, S1, we do like to enter the roll number and average. For example, roll number is 100, average is, for example, 9.8. Press enter, then it prompts, right, for the second student, enter the roll number and average. For example, the second student roll number is 101, the average is say 9.5. So S1 dot input, right, execution is over. Then S2 dot, right, S1 dot get input, execution is over. S2 dot get input, execution is over. Then the next statements to be executed are S1 dot display and S2 dot display. So S1 dot display, right, what happens? The control is transferred to execute the display function using the object S1. So wherever, right, whenever you are mentioning the data member of the class, for example, roll number and average, that is actually being accessed by the invoking object. So when S1 is calling the display, it prints, right, the roll number and average corresponding to the object S1. And when S2 calls the function display, when it accesses the cout statement, roll number and avg, that is the actual value of calling object or invoking object S2. So if we press enter, right, we expect the results, right, in an order. For the first student, right, the call of S1 dot display that results in roll number is 100, average is say 9.8, and for the second student, because of the second call S2 dot display, that displays the values of the invoking object, say S2. So S2's roll number and S2's average are printed. S2's roll number is 101. S2's average is 9.5. That we have given as the input. So this is the logic of, right, the writing or object-oriented C++ program. So to write the object-oriented C++ program, please keep in mind that we need to follow these important sections. First section, right, or first section, you need to include the relevant header files. Hash include, right, include this directives, preprocessor directives, right, include the necessary header files. Say hash include iostream.h, hash include iomanip.h, hash include math.h. Like that, you can define, right, any number of header files, include the header files. Following that include the class declaration, class definition, right? That can be right done using this general form. Class name, opening curly brace and closing curly brace followed by semicolon. So within this region, right, this is the place where we can define, right, the data members and the variables, functions. So data members, right, that means variables and functions can be defined, right, inside the scope of the class declaration like this. Variable declaration part, function definition part. Assuming the function definition takes small number of quotes, right, minimal number of quotes, say 2, 3, 4, 5, that can be placed, right, as a part of automatic inlining. That means the function definition is included in the part of a class declaration. Then you need to call the functions or class variables, right? That means class members using the dot operator. To employ that, you must have created the relevant objects. So student S1, right? The object S1 is created. Student S2, right? The object S2 is created. Or this is equal to a two-step process. Student S1 semicolon, then student S2 semicolon. To call the member functions, you must use the object. That is important. So the syntax to call the member function is object name dot member function name. This is object name, right? S1 dot, right? Member function name is S1 dot input. Likewise, object is S2. Member function name is say get input. The function, right, does not take any actual parameters. So actual parameter list is empty. Here also the formal parameter list is empty. Then to print the value, right, have a display function s1.displays the invoking object, right, the calling object. Calling object is s1. So when s1.display is called, wherever the class members are there, like this roll number, avg, these are invoked by the calling object or invoking object s1, so that the contents of s1 is printed. Then the second call s2.display, right, the contents of s2 are going to be printed. This is the logic of, right, object oriented C++ program. So just to have the fundamentals, what is an object, what is a class, how to define the class in C++, right? How to define the member functions, how to create an object, how an object can call the corresponding data member or member functions, right? This is a fundamentals, right? Still we need to verify, right, some more rules, right? Accessing rules of classes and objects. We will verify the accessing rules of classes and objects, right, in the next session. Now it's time for you, right, to ask your queries. Have any queries, right? Please ask. Have any queries, doubts?
No, sir.
Okay. Please go through the session topics, right? Materials. We will discuss in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.